we've made one change this year, which is to have two papers presented in each CAFFE seminar instead of a single paper. And the two papers are typically going to be on the same theme. And the theme for today is the use of artificial intelligence for doing research in finance and economics. So we have two experts to teach us today really how to use AI to make life easier so that all of us can be more productive and more efficient. And so our first speaker is going to be Anton Korinek, and then the second speaker will be Bryan. So we'll start with Anton. Anton, the screen is yours.
Thank you. I think, okay, now I can share screen. Thank you very much for having me and for having us, because I look forward to learning from Kevin as well. We are all still figuring out how to use these new generative AI tools, and for now, mostly large language models, for accelerating our research in economics and finance. So what this paper is about, it's essentially based on my own explorations of largely GPT-4, but also a couple of other models like Claude, for example, and how I found them to be useful for my research. And I should also say, this is a paper of which I wrote the first version in February before we had GPT-4. And things were not quite as useful yet, but I could already see the glimmers of where this is going. And then I had to revise it in July when GPT-4 was out, Claude 2 was out, and it was really amazing how much progress we had seen in between. And now the paper is forthcoming in the Journal of Economic Literature. So let me dive right into the topic. First, I want to observe that we really are in a new paradigm for AI. In the 2010s, many of us played around with various applications of deep learning. So deep learning was a powerful technology. It had a large impact, but there was still always this category difference between human intelligence and AI. And now we are in this new paradigm of foundation models, which are the models powering generative AI systems. And of course, that builds on deep learning, but also it feels qualitatively different. When you interact with these chatbots, we of course know they are not human, but it feels eerily human-like. And I wonder if part of that is that the parameter count and number of neurons and so on of these models are coming close to the complexity of our human brains. So the leading category right now are large language models like ChatGPT powered by GPT-4, but there are also others like Google has Bard, is soon expected to come out, which is a system that will be more powerful than GPT-4, called Gemini. There's Claude, Llama, and so on. So as economists, kind of one background question we're all wondering about is, what is driving all this? And there is, of course, Moore's law, computing capacity doubling every 2 years, but that's really nothing compared to what's going on in the space of foundation models. What I'm showing here is a graph that shows the amount of training compute. So the number of computations going into training the most cutting edge systems. And we can see that this training compute has doubled every 6 months for the past essentially 15 years. And we are still on that same trajectory. When Google Gemini will come out, it's going to correspond to like a doubling every 6 months. And I think we can expect this to continue for at least a few more years. So we've all encountered when we talk about these systems that there are two camps on the significance of these large language models. There's the stochastic parrot camp that emphasizes all the limitations. It says, well, this is just stupid advanced autocomplete. And then there's the, let's call it human level AI camp that emphasizes all the amazing capabilities. And I have to say, I can relate to both because it's so easy to both over, but also underestimate the current language models. And I want to suggest it's actually dangerous to do either of the two, because the capabilities and the quote unquote intelligence of these systems is so different from ours. But what I want to focus on in this paper is not whether they are close to human level or whether they're really dumb stochastic parrots. I just want to claim that they are actually really useful in conducting research. And that's what I'm focusing on now. So one slide on the training of these systems, because that kind of helps with understanding what to do when we prompt them. All these models are basically pre-trained using a process called self-supervised learning. And it's a very expensive process. So for example, for GPT-4, the cutting edge OpenAI system, or Google's Gemini, the cost of the final training run, so of the last time that you pressed the run and you executed your program, is more than $100 million. And during this pre-training, these systems are fed vast amounts of data with a really banal training objective to predict the next word or token, technically speaking, in every sentence. And I should also say the pure text-based models are increasingly augmented with other modalities like images, sound, and so on. So how should we think about this banal training process leading to pretty powerful capabilities? Well, I think one of the best explanations is that if you want to be able to continue any given sentence in the world in a reasonable manner, you need to develop a representation of the world. And that representation of the world, or some people are calling it world model, is what these systems are basing their responses on. So whenever we query GPT-4 or soon Gemini and so on, they are drawing on an internal representation of the world that is probably already broader than that of any given human, because we can fit only so much into our brain. But it's not as deep as, for example, what we know in economic research. And I think that thinking about what the models can and cannot do is one of the most helpful approaches, at least to me. So my own advice is when you interact with these systems, treat them as if they were an intern who is very smart and motivated and eager to help, but is at a somewhat more basic level than what we are. And they completely lack the context of what we are doing. And they have their own idiosyncratic weaknesses. It's like if you onboard a new employee, you need to learn what are their strengths and weaknesses, what can you best outsource to them, what do you better keep for yourself. So based on that, I would say provide as much context as you can, iterate, and also to some extent be patient if you need to do some iteration. Oftentimes you won't get what you want the first time you try it, but if you iterate a bit, you will get much better results. All right, so a few things about limitations that we need to be aware of. I need to kind of hurry so that we get to the actual applications. First thing, these systems are not very good for analytic concepts yet. They're language models, but they don't work in the way that we traditionally think about computers. For example, if you ask them to multiply 3-digit numbers, the result that they'll come up with is going to be most likely garbage. There is a training data cutoff that is fall 2021 for GPT 3.5 or 4, but for example, Google systems, it is much more recent. There is a limited amount of text that these systems can digest. So ChatGPT, for example, can only take about 3,000 words. There are other systems that we can resort to that can digest much more. For example, I will show a use case of a system called Claude 2 that can digest up to 100,000 tokens that corresponds about to 75,000 words. And then the other thing, when you start using these systems, to keep in mind is that they completely forget what you did in previous sessions. So if you work in one session on one topic, and then the next day you open up a new session, they have forgotten everything you have done. And finally, there's some randomness, which limits the reproducibility of these systems, even if we set the randomness parameter, which is called temperature parameter, to 0. Now, I should say many of these limitations are being pushed out. We are seeing new models released every month. So, for example, I would imagine when we see Google's Gemini, it's going to have improved on a number of these limitations here. There are also risks: information security, hallucination. These systems are prone to make up things, bias. The output builds on the training data, and given our human culture, there are certain biases embedded in it, and the risk of homogeneity. If we all use the same system, we'll all get similar outputs. So we as researchers, we have to kind of counteract all these things. We have to keep them in check. We have to make sure we avoid excessive homogeneity, we lean against bias, and so on. So now I want to get to the actual use cases, and I have categorized them into 6 different buckets. I will cover only 3 of those today because I will then hand it over to Kevin, who has prepared some much more in-depth lessons for us that I also look forward to myself. I start with ideation and feedback, because in some ways that's what distinguishes the current systems the most from the AI applications that we are used to, or I should say the computer systems we are used to. We are not used to AI, or let's say computers, being particularly creative. But my claim here in this section is that systems like GPT-4 can actually be genuinely creative in a way that is useful for us as researchers. So this is just a whole list of examples. It's in the paper if you are interested. So when I talk about ideation, that means generating, selecting, developing ideas. And I should say I know many colleagues by now who are regularly employing GPT-4 to have like a back and forth on the topics of their papers. And yeah, the 4 examples that I offer are: first, a brainstorming example, a feedback example, an example where the language models provide counter arguments, and then also one where they evaluate ideas. So this is the first exhibit in the paper. I'm asking, and I have to move a few things on my screen around so I can actually read it. I'm asking GPT-4, can you brainstorm 20 channels through which AI may increase inequality? And then I'm asking it to limit its response so that I can fit it on one page. And you can see that GPT-4 came up with a long list of things, many of which are honestly pretty generic, some of which I honestly didn't really think about. And it is one of those situations where speed and quantity kind of generates its own form of quality. So even though you can say, well, this is perhaps a little generic, the fact that you can get it within like 10 seconds and that you have such a long list makes it useful in its own right, because there are a couple in there that I wouldn't have naturally thought about. And sometimes just getting one idea can be extremely useful when we conduct research. Now, my next use case is, I'll have to move things on my screen again, using Claude 2, which is an alternative AI system, an alternative large language model by Anthropic. And what I did is I fed the working paper version of this very paper that I'm presenting now into Claude 2. And I asked it, can you suggest ways to improve this paper? And it came up with a long list. I'm showing you just one part of it here on how I could potentially improve it. It said provide more specific details and examples. Some of the explanations are a bit vague. Second bullet, expand the discussions of the limitations and potential downsides. Third point, strengthen the analysis of the long-term implications. It is a bit speculative, and so on. And to be honest, several of these points were actually picked up by the referees of the first version as well. So I would say it was actually a pretty appropriate critique of the paper. Now, the next thing that I did, and that made me feel a little bit eerie, is I asked Claude, can you write a referee report for this paper for the Journal of Economic Literature? And Claude proceeded to, I think it gave me some disclaimer that this is a draft. It proceeded to write a referee report, which honestly, it wasn't the most thoughtful I've ever seen, but it really wasn't that bad. And it also picked up on several points that the true, presumably human referees had picked up on. So then I got a little bit more courage as I thought, well, let me see how this works and let me see what it says. If I ask it, can you write a referee report for the AER? And this paper is clearly not suitable for the AER because it's purely methodological and it doesn't offer any novel economic insights. So Claude 2 actually wrote that. It wrote, this paper is not suitable for the American Economic Review. And then it gave me a few suggestions for what type of paper would be more suitable. If you're interested, you can see the whole exchange in the appendix of the final version of the paper. So yeah, this is a little bit eerie, right? We are at the point where large language models can draft referee reports, and not even the worst ones. Although I should also add that they're language models. So for a paper like this one, which focuses mostly on explaining things and doesn't have a lot of math, it works. For a more analytic paper, the language model cannot really pick up on whether, for example, the derivations are correct. That's still beyond their capabilities. So one more, no more example on ideation, but I just wanted to point out it can offer feedback on ideas. It can discuss the pros and cons of different research approaches and so on. My second category of use cases is for writing, because in some ways language models are the most natural at writing. And so they are pretty powerful at lots of things in the realm of writing. I regularly use these models to synthesize text. So for example, I jot down bullet points and ask them to convert it into well-phrased prose. I ask them to provide examples, to evaluate text, to edit text, to generate titles and headlines, and also to generate tweets. So let me show you a few specific examples of that. Here, I'm demonstrating how I'm using essentially like bullet points and ask the language model to convert it into full sentences and paragraphs. And you can see I have listed a few bullet points that are kind of like from the introduction of this paper. And the language model writes a pretty well-formed sentence that captures exactly what I want. So making this useful as part of your workflow takes a little bit of trial and error. You want to give it enough instructions so that it writes what you want. But if you give it too many instructions, then you're faster writing it yourself. So you have to find the sweet spot in between. Another example that's really very relevant for people who are not native speakers. Can you correct the following sentence? Or you can do this for paragraphs and whole pages or sections of papers. I have completely screwed up a sentence here in the initial prompt. I've introduced, I think, 6 or 7 different mistakes, and the language model catches all of them and comes out with a correct sentence. And then GPT-4 can even explain the corrections that it made, although I think it omitted one of them. But that means that any of our graduate students who are polishing up their papers, for example, for the job market season right now, they really have no more excuse if their papers are not well written, because they can feed this all into language models. And I'm telling all my students to do that. Evaluating style. So here I'm asking, again, GPT-4 to give a concise list of the top 5 stylistic shortcomings of the abstract of this paper. And well, I'll have to admit it was a little bit deflating, but I think all the points are correct. So first it says lack of clarity, overuse of passive voice, lack of specificity, redundancy, lack of structure, and it explains, it makes each of these points more tangible. And I think it's spot on. Part of it is the problem that if we write an abstract, we want to really condense a lot of things into it. But yeah, there are lots of scopes for improvement. And in fact, in the next prompt, I asked GPT-4, can you improve the paragraph by taking into account your critique? And it did a semi-decent job at it, so I'd probably edit this further, but it made it more tangibly easier to read, less dense, and so on. Further examples. So these language models, they're really good at changing style, rewriting things. You can, for example, when you have written an academic paper, you can ask it to write a summary for a blog post. And usually that's pretty good. You don't even have to do much post-editing. Can you write a summary that's accessible to policymakers or in the style of, and you can pick your favorite economist or politician or comedian. You can also ask it to evaluate things like what is hard to follow in this text, what is unclear, is this coherent, and so on. Now, the next example, I regularly ask these systems to help me brainstorm titles. And this is where this creativity that I mentioned in the beginning really plays out again. If you have, 20 ideas for a title, you can kind of pick and choose words and strategies. And I found it really helpful. I found it to produce lots of useful things, and usually I pick and choose a few things from a few different examples and make it my own. And yeah, you can also tell it which style. So here in the second box, I'm asking it to make it a bit more sober and keep it shorter. And you will notice the first one it gave here is kind of similar to the title I ended up with for this paper. Okay, so another use case is when you have finished your paper and you want to advertise it on social media, you can just ask GPT or Claude to draft a few tweets. And usually these are pretty good. So maybe you want to edit a little bit here or there, but it saves a ton of time to just do that. And you can tweet out your paper and advertise it. Now, the third set of capabilities that I will cover before I hand over to Kevin is that there are some use cases in the context of background research, although this is something where we really have to be careful still when we use these models. So first of all, researching the literature. This is something where language models routinely make up stuff. So it means you can never trust them when you ask it to write a literature summary on some topic. It also isn't very well calibrated sometimes. So it sometimes lists papers that are not the top papers in a given literature. It can summarize text. That's something that is actually very good at. Can format references, which is, one of these tasks that we typically always outsourced to RAs, but now it works within seconds. Now even GPT 3.5 can do this. And then finally, and I think this is something that all our students are using these systems for, it can also explain concepts. And usually a system like GPT-4 is actually pretty good at this, but I will show you one example where I'll jump over a few things. I'll show you one example that was really interesting and it's instructive. I asked GPT 3.5, so this was actually first in the original version of the paper in February, what is the second theorem of welfare economics? And it states the second theorem states that any competitive equilibrium is Pareto efficient. So I paused for a moment. I was like, hold on. And then I was unsure myself. This is clearly the first theorem, not the second theorem, right? And I engaged even in some back and forth, and GPT 3.5 insisted that this is the second theorem. And it just confused the two. So when I asked about the first, it stated the second. When I asked about the second, it stated the first. So this is one of those examples where we can see that we really have to be also careful using these systems. And we have to be aware that they regularly hallucinate. And since our students are already using them as tutors, this is making for interesting teaching times. All right, there is a whole bunch of further examples and further discussions on what this means for economics, but I'll hand it over to Kevin now. And I have to, okay, great.
Thank you very much, Anton. Our second speaker is Kevin Bryan from the University of Toronto. Kevin is not an economist or a financial economist, but he has still agreed to talk to us about economic research. And he's doing very interesting things with AI that he's going to share with us now. So over to you, Kevin.
Great, thank you, Raman. And yeah, don't worry, I'm not a finance economist, but I'm definitely an economist. Though oddly, most of my work is just theory. So even for a theorist, I'll show you some good use cases. I should start, by the way, by saying that you should read Anton's full paper. If you hadn't, he mentioned it's coming out in JEL. It's actually, I think nothing's quite announced yet, but it's a really cool experiment related to his paper in JEL. That's being tried out. So I'm sure you'll see details on this in a few months when the paper's ready. But I think it's a super interesting new way to handle publishing on fast-moving topics. So on that note, I'm going to take you through some of the use cases for LLMs, largely on the API side. What I mean by that is not using the ChatGPT interface or the Claude interface, but by making calls to an API in Python or R or whatever software you use. And there's some just like back end of research tasks that it turns out you can do very, very cheaply and at higher quality than was possible with, like in my case, I'll give you an example where we spent tens of thousands of dollars coding up quite a complicated neural net a few years ago. And now I can, for like literally pennies, I can beat it in accuracy. So before I do that, I need to walk you through real quick just a technical detail of how an LLM works, because you won't really understand what the API calls are doing unless you really understand what generative AI does. So some people say they're worried and they think an LLM is a stochastic parrot, as Anton Korinek mentioned, meaning I'm just trying to predict the next word with some randomness. So if I write the sun ... you're going to say something like the sun is, or the sun shines, or the sun rose, or something like that. And there's some probability distribution on the next word in the entire corpus of English language ever written. Likewise for German or Spanish or French or Hindi or whatever language you use. Okay, obviously if I change it a little bit, so I write Le Soleil, then it's going to be Le Soleil, right? So this problem actually is not terribly hard. We don't need generative AI to do it. So you can imagine I can, with knowing nothing about how to create an algorithm. So all I'm going to do is I'm going to take the entire corpus of, say, English language text. I'm going to create the probability distribution of the next words that follow le soleil or that follow the sun. I'm going to give you that distribution, and then I'm just going to start predicting next word, next word, next word, next word, next word. This is so easy, you could just do it yourself, and like your phone basically does it and has done it for years, right? When you're sending a text, it might give you that next word prediction. So you don't need generative AI to do that, but it doesn't work very well. So for example, if I were to say the sun at Yosemite, that's a famous national park in the United States, shines brightly across the, okay, so I'm trying to predict the next word, and all I know is the, it might be who the heck knows. If you told me across the, so maybe I would say room or hallway, but that doesn't make sense in this context because I'm saying something about the sun at a big national park shining. And so what I really want is something like the face of Half Dome. That's the famous spot people go to at Yosemite to see the sunrise. And so essentially all that's going on and all that's new with the so-called transformer architecture, which was invented in 2017, you can think of the easiest possible way to do text prediction is just this. Give me the distribution of words in the language I'm trying to predict the next word. Maybe a slight modification. Instead of giving you the exact words, I'm going to embed these words in a lower dimensional space so that soleil or sun is kind of in a similar space as the word sun's not a good one because there's not a lot of synonyms, but similar place to a synonym in the lower dimensional space. And then even if the exact words I've typed have never appeared in English or in French, I can still predict the next word. That's called an embedding. But we're still going to run into this problem. So this problem that it's really, really hard to remember the context that we're trying to pay attention to as we go further and further back. And this is relatively easy. It's only a few words before the next word we're trying to create. But imagine that the relevant context is like 4 sentences before or like a page before. As an English reader, it wouldn't be a problem. But for a computer, that's really hard. So what people did was that they created algorithms that do that next word or next token prediction that try to remember some of the context that's come before. So you may have heard of things like RNNs or CNNs. And essentially, these are just ways to try to remember the relevant context of the past as I get to the next word. The problem is they're fairly slow for a lot of applications, especially CNNs. And they don't actually do a good job of remembering the proper context. So the idea in the paper that makes GPT possible, so GPT, the T in GPT is transformer. The transformer paper from Google in 2017 basically says, let's just act like a person. So if I was trying to get the next word here on across the, what should it be? You as a person would look, okay, sun and Yosemite and across, those are all fairly relevant, right? Whereas this word at and brightly is not as relevant, okay? So when I'm trying to predict the next word, I want to kind of overweight the word sun and Yosemite and across and underweight all the rest. And that allows me to save a little bit on essentially what the architecture or what the algorithm is trying to remember. So literally this is called attention. The famous paper is called Attention is All You Need. And the idea here is this is just a very fast way to remember or to create some kind of long-term memory in predicting a next token. In this case, a token is more or less a word, but you can imagine the same thing for predicting a pixel on a picture or predicting a note in music or many other contexts. So that's all that's happening in an LLM is that we're using this attention to focus on the stuff in the past that's most relevant. That's going to update a posterior distribution of the next word that could appear. We're actually going to use something called multi-beam attention to predict the posterior of the next few words and not just the next word. But that's everything. So now you understand. When I'm trying to control an LLM, what I'm trying to do is I'm trying to shift the posterior distribution of next word predictions, given that they're coming from this attention-seeking mechanism whose whole point is to figure out the words in the past that are the most relevant to predicting the next few words after what you're writing. That's all that's going on in the algorithm. Now, amazingly, this works okay if you feed it basically all the language written in English on the internet, written in some language on the internet, or all the Python code in the internet. It does like a shockingly good job. People were very surprised, okay? So this basic idea of deep learning and the idea of trying to focus on the relevant parts of long-term memory is very old. Actually, it goes back decades. But it turns out that when we give these models this huge corpora of text, they do really well. And maybe it's not that surprising. So, for example, if I gave you the sentence, tell me whether this sentence is discussing foreign affairs or economics, the inflation rate rose to 3.2% yesterday, said the Fed. Okay, the next word. So you think about this and you think, okay, the relevant stuff here is this, tell me this sentence discussing foreign affairs or economics, okay, inflation, Fed, and you would just say the next word should be economics. And if you think about it, it's not that hard. You might imagine if I have all the text ever written on the internet and I have a clever enough algorithm that focuses on which parts of this prior text I should heavily weight for predicting the next word, that I'm going to get the posterior right. So this is a very easy problem for an LLM. So everything you're going to do when you use an LLM is about shifting posterior distributions of next word prediction. That's it, okay? I would say there are 4 ways you can do this. The simplest way is what you're doing when you just go onto like the ChatGPT interface. This is called zero-shot prompt engineering. So zero-shot means I don't give any examples of what I'm looking for. I just write some text. So let me hear a story. Tell me about the weather yesterday, the sun, ... So the next word is going to predict like was. So it won't say is. You've given it enough context by saying yesterday that attention mechanism is not going to put is here, but it's not super controlled. We can do a little better if I add some context. There's actually a way to do this directly in either the ChatGPT interface or in the API for GPT or for Claude or for any of these actually. And so I'll say, okay, the context of our conversation are stories written by Hemingway. And so then I say the sun, ... And since I've given this talk in person, and us economists, unfortunately, are all illiterates because not everyone knows that the next word should be also. But hopefully, those of you here have read books and you know why if the context is Hemingway, the next word will be also with high probability. The third thing I can do, which is really getting better, is I'm going to feed the API a few shot context, meaning I'm going to give it examples of exactly how I want it to respond. So I'll go something like X, the moon, A, orbits 100,000 miles from Earth, X, Mars, orbits 50 million miles from Earth. Example, Pluto, answer, orbits 1 billion miles from Earth. These are all made up numbers, by the way, I'm not an astronomer. And I say the sun, and I'm going to feed it, and of course, it's going to say something like orbits 93 million miles from Earth. Why is it doing this? Because the attention mechanism is updating the posterior of next word prediction. By the way, as Anton has pointed out, there's no particular reason it needs to give you true things when all it's doing is focusing on attention and updating. So I gave this talk so many times, actually, that I forgot the first time I wrote this, I deliberately made this complete nonsense. So for instance, the moon does not, Mars does not orbit Earth, right? Neither does Pluto orbit Earth, neither does the sun. But nonetheless, because I've given this context, the LLM is going to write the correct distance, but it's going to give some nonsense about what the sun's doing in relation to Earth. Okay. And the reason I forgot was that people are so excited about LLMs that it took like a few talks before someone was like, wait a second, this seems completely wrong. And I was like, oh yes, that's on purpose. All right, the fourth thing I can do is I can fine tune. If I want to change the posterior distribution of next word prediction, what I can do is I can just retrain the LLM. So retrain what the prediction of next words on a different corpus of text. Generally, what I'm going to do is I'm going to use a huge corpus of text the LLM's already trained on, and I'm just going to slightly update it with this fine-tuning. That's why it's called fine-tuning. So imagine I just gave an LLM a ton of 2023 written astronomy papers that are academic papers, and then I told it the sun. Then it's going to say something like emits or some kind of a word distribution that's more familiar from academic papers. So when I think through these methods for controlling the posterior distribution, we can think of the first one as what we call prompt engineering. The second one is maybe contextual prompting, and the last one's called fine tuning. I think in general, For almost all of your use cases, you'll be using method 2 or 3 that works the best. So method 1 is so cheap that it's basically free because you can just use the web interface. It's often imprecise and quite hard to control, I find, although Anton's giving you some great examples where it's totally sufficient. Fine tuning is very expensive. So if you're using, say, GPT's API and you want to fine tune a model and then call an API referring to that model, you should be thinking, I'm paying on the order of 20 to 100x per word I receive back, which can add up quite quickly. So methods 2 and 3 turn out to be very useful. They combine being cheap with being actually quite easy to control. Okay, I'm going to just skip that for time. So Anton's already shown you a couple of examples like C, this super spell check or grammar check actually works better than anything you've used before. Even better than that, obviously LLMs are being integrated into things like Microsoft Word and Grammarly and whatever, and we're very, very, very close to having to not paste anything into an LLM because it'll just be the table stakes of using any software that'll have the LLM in the background. I'm summarizing literature as well. Anton, I'll show you some examples. I'll show you actually a great way to do this even for super, super, super huge corpus of literature, like way bigger than what you can fit in the window of Claude or GPT. Math and derivations generally is not a good use case at the moment, though I can think how I could do this with code to make it work perfectly by combining an LLM with other APIs, and it does work very well. And so I think we're very, very close. I would be shocked if in a couple of years you can't check your proofs actually with an LLM. But I'm going to focus on the first two. So entity recognition and speeding up programming. And then this is just for later, just for people watching it. I would say critical things to observe. It's not trivial to control the output. In fact, as Anton mentions, even with setting the temperature to 0, which is a parameter you can control in GPT's API, it's not perfectly deterministic, which makes replication a bit tough. Raw ChatGPT is far from the state of the art. So if you use it and you think this doesn't seem to be doing as well as I would expect, understand like even in October 2023, it's not the state of the art. And in October 2024, it definitely won't be. Hallucinations, everyone worries about, meaning made up facts. I'll show you how to fix that. That's actually not that hard. Rate of improvement, super quick. And the cost is just incredibly cheap. So some examples. This is from a paper of mine. I'm using patent data here. And essentially the problem I'm trying to solve is that I would like to know why this inventor has drawn on a particular piece of evidence. So let's focus on right here at the top. You see this this quote to this paper by Barak et al. In Journal of Biological Chemistry that beta AR2 GFP trafficking was visualized in transfected cells on a heated microscope stage as described in Barak et al. Images were collected sequentially, ... So if I read that to you, you would say, oh, I see. That Barak paper is being cited because it was a tool or a technique used by the inventor to make their invention, okay? And if I surveyed the inventor and asked them that, they would tell me that as well. And so I did survey a bunch of inventors with a couple of colleagues. That survey cost $40 per response that we got. So it's super, super expensive. We'd like to not do this. So what we're going to do is we're going to try to predict for like the million other references to science in the patent corpus, why that particular patent is being referenced the way it is. So we've done this with like a neural net, like old-fashioned deep learning. It works pretty well. It turns out I can do better straight out of the box with a GPT API. So we're going to do code that looks just like this. So I'm going to pass these instructions in Python to GPT. This is the whole thing I need to pass. There's just one more line to kind of receive the answer and one more line to pass your key that lets you pay for this. But basically, let's just say, here's the text I just showed you. We'll call that patent. Then I'll give a bunch of instructions on what I'm asking for. I'll show you that in a second. Send to GPT. Here I'm using 3.5, so it's actually not GPT-4, just to save money. Set temperature to 0 to make this as deterministic as I can. And consider a few instructions. So consider this sample from a patent. We want to know why the paper was used, potential reasons or general background, a use case, a tool or technique. State first, background knowledge, tool, technique, or example use, then state why you think the state article was cited by this inventor. Actually, we can do even better now. With some tools they've just added to the API recently, I can exactly control what these last tokens is going to give me are. But in any case, I can do that. Or maybe you're wondering, maybe that's not the right way to ask it. So let's change it a little bit. Like, The user wants to know why the stated article was cited by the inventor. I've just slightly changed the text. Or maybe you want to do a few shot context prompting. So here, consider the sample from a patent. I want to know why it was cited. And then I give a few examples of ground truth from my data set. Okay, then I pass that. And do I have to choose? No, because it's so cheap. What I'm going to do is I'm going to use what's called an ensemble method. So I'm just going to pass all these to GPT, pay like 0.3 cents each time I do it, and then just have the plurality vote be chosen as the truth. In this case, actually, it turns out that they all three correctly say this is a tool or technique. They all exactly correctly state why. And this cost, where it says 485 here, 3,000 tokens is 1 US cent, to give you an idea of how cheap this is. So I can do this for $1 million, and it's not really a problem. It's way, 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 way cheaper than other things I've tried to do. Okay, so this kind of entity recognition, a great use case for the GPT API with a little bit of training or appropriately chosen context in that few shot context. It actually does better than a state-of-the-art convolutional neural net that we trained a few years ago, where the convolutional neural net sees 10,000 pieces of ground truth. This sees 3, and it still does better. Why? Because it understands the English language in a similar way that you do, using this attention mechanism. Second example, all the time we have garbage like this. This is, my friend was at the National Archives of the United States. He wanted some old data from the NIH on scientist contracts. They gave him a floppy disk, you know, like one of those old disks. Like, I don't even know where you're going to find a computer hookup to put that in to even take it off. So finally he found that, he took it off. And what he found was that all this data was stored in a format that he doesn't even know what the format is. It's got all these symbols that is just hard to interpret. It looks kind of like, if you stare at this, like this must be some kind of a CVs of scientists, probably. And there is some type of regular nature to it. If you stare at it long enough, you could probably interpret this, but don't worry. I'm just going to pass this straight to the API with a few instructions to say, this is data on scientist record from the NIH. The format is unknown. Can you try to clean this up, etc.? And no problem. You'll see right here at the top, this is Oscar Abo, who was at Brown, PhD history and math, then a visiting lecturer at Washington University. That's what it says on the top, and no problem. So GPT is going to correctly pull out this person's CV. Probably not going to do it perfectly, but much faster than alternatives that you might have tried. Actually, I talked to when I was talking to Marcus Brunnermeyer about this a few months ago. He had some data that was handwritten, then OCR'd German financial records from like 1900 that had like even like spelling things correctly was not that easy for an RA because the handwriting was so rough. But it turns out that GPT could clean up the OCR in a really nice way and save them just tons of time, where the RAs could just then check things later. I'll give you an example of how good this is. So this is from a paper of mine. Don't worry, it's not a very good paper. So if you OCR this, I don't know if you've ever OCR'd old historical documents. It's bad enough, but OCRing LaTeX, man, I don't know why LaTeX stores the format so weird that it's hard to often copy and paste from a PDF, but it does. So I tried to OCR this just with Adobe Acrobat, and it gave me this text on the left, like consider RST 3 results, which are either known, if pi are known, like it's completely wrong, okay? Like there's just mistakes absolutely everywhere. So what I did was, again, I created an API call, just like we saw before. I told them that this came from a mathematical document that had been OCR'd, that there were errors. Actually, I didn't give it any context, though I could have. I'll show you some examples of ones I would do. And I said, clean this up, and not only clean it up, but put it back into LaTeX code if you could. It did. It gave me this. And here you see, like, obviously the consider first, that it knows that RST should be first, was a fairly easy problem. So it fixed this ligature that you see here on the FI in the PDF. But even things like, you know, here it says if pi are independent. Now, you know, pi are independent doesn't make any sense. Maybe pi is independent, but I don't even know how that doesn't make much sense either. So I see all this context. I see this 1 minus pi pj. Okay, now I think, oh, it must be p sub I. I can do that myself. And it turns out no problem also for GPT to figure out that pi should have been p sub I. I think there's one mistake in this whole thing, and actually looking back at the OCR, it's literally not possible to fix even for a human because it just didn't show up at all in the OCR. So cleaning up text, a really good use case, especially if you work with historical data. And last, is code. So if you're teaching, you're writing a paper all the time, you probably need to generate some code. If you don't use Python right now, I highly recommend stopping using Stata, because it turns out the amount of Python on the internet is like 100x the amount of Stata, and hence these LLMs are perfect at writing Python and not very good actually at writing Stata. So your code will be much cleaner. But let's imagine I'm teaching a class and I just want to show this. I want to show a graphic of a supply and demand curve. Super annoying to do. So I just gave this, actually this one you can probably just give straight to the ChatGPT window, no need to use an API. And it's going to give you this. It looks right, but you're an economist. So you look at this and you're like, it's almost right. But thanks to our friend, Mr. Corneau, we put price on the y-axis and quantity on the x-axis, not quantity on the y and price on the x, but no problem. I just go, that's pretty good. Remember the supply and demand graph, P's on Y and Q's on X. Also make the axes go to 0. If you look here in the corner, kind of annoying that it didn't go to 0. We want this to be clean. So instead of cleaning that up by hand and wasting a few minutes, I just typed that in and now it's totally fixed. So suffice to say, there's a lot of coding tasks that are much, much quicker. In research papers looking at programming, even good programmers can do tasks on the order of 50% quicker using GitHub Copilot or using an LLM. For weaker programmers, it's more like a doubling. In my case, I'm so weak, it's actually more than a doubling in my case. So I can program much, much, much faster. I mean, like literally creating this graph, I don't know, would it take me a few minutes probably? And now for class, and now it takes me 0.2 seconds. All right, last thing, summarization. So I told you that we can summarize text. Anton showed you an example where we use Claude to give it a bigger context, but imagine I have thousands and thousands and thousands of pages. So in my case, I had my folder on my computer with every paper that I've saved. I'm an innovation economist, so all sorts of innovation papers. There's like literally 1,000. So there's no chance of ever passing this to an API. And if you paid for it, it'd be quite expensive because you pay by the token that you pass. So what I did was, instead of using raw LLMs, just a little bit of cleverness, okay? Just like if you want your LLM to do math, just ask the LLM what the math is and then pass that math to a different program, like pass it to NumPy and ask it to do the computation. You can also use the LLM in conjunction with a little code. So this is maybe 30 lines of code. I took all of my PDFs in my folder. I chunked them into blocks of text, overlapping blocks of a few hundred words of text. I embedded them into some lower dimensional space. I ask a question like, give me the sample size and main methodology of the Bryan et al. Startup hiring paper. This is a paper, an experiment I wrote. I didn't tell it the name of the paper or anything, but by comparing the cosine similarity of this question with all those embeddings I saw, and then just grabbing a handful of the most similar ones, then passing all that context to an LLM, it actually completely correctly summarizes this paper. So effectively, I'm using a context window of like millions and millions and millions and millions and millions and millions of tokens, okay? But I'm paying for like 2,000 tokens, so I'm doing this question for, a half penny or something like that, which is obviously much better. So I use this all the time on my own computer when I'm trying to remember what was the right paper that did this, what were the details of this. And by the way, I've also built in some stuff here to avoid hallucination. So it's just not going to show me the answer until I ask follow-up questions in the background to confirm that all the details here are actually pulled directly from the context. So very easy to avoid hallucination with a little bit of extra work. And in fact, since we're here at the CEPR talk, the nice thing also is that even though these papers are written in English, don't worry, because of the way text embeddings work, it's very easy to use different languages for the question and for the answer, or the question and the context. So you can ask your question in German, it will give you the exact same answer translated into German and correctly find the right context. So I think we want to save a little time for questions, so I'm going to stop there. Thank you very much to Raman and the organizers, and to Anton. I always learn a lot from you, buddy, and hopefully you guys learned a lot as well.
Thank you very much, Kevin. I encourage you to look at Kevin's webpage and GitHub page, because there's a lot of stuff that you can piggyback on. But we'll open it up for questions now. And if you can first say who you are directing your question to, Anton or Kevin, and then ask your question, please go ahead. So you can just unmute yourself and ask a question if you want to raise your hand, I can call on you. That's also fine. Okay. So the floor is open to questions. So Kevin, like maybe I can start, like how difficult is it to use the APIs? Like, do I need to spend a few days learning how to do this, or it's going to take me a few weeks to catch up to where you are?
So to use it in terms of understanding the syntax, Anton, what would you do if you didn't know how to use the GPT syntax?
I would go to ChatGPT and I would ask it, how do I use the OpenAI API?
Of
And
course.
you can ask it any follow-up questions and it will explain it in detail. And in fact, that's exactly what I did to learn it.
Yeah, of course. And if you want to use, say, some new part of the API that, as Anton mentioned, ChatGPT's context window only goes up through late 2021. I think Claude goes through actually the end of 2022. So it should have everything. Actually, the API, I guess, started in 2023. So none of them should have the full context, but you can also paste in any of the documents into the context window, then ask questions on that, and it'll be able to handle it quite well.
Google Bard can already explain it based on its pre-training data.
Perfect. So there you go. Yeah, so that's for the syntax. Now, the technical details of like what works and what doesn't, I would play around a little bit. Hopefully, like from the talk today, you have a better understanding of what's going on under the hood. Like a lot of people don't realize, for example, that it's actually not only is it not deterministic, it's not obvious how you, given something called the feed forward mechanism, it's not even obvious how you would make it deterministic, which might be a problem for some use cases for research. But to learn that, I think you'll just kind of figure out as you do a bit of reading if you wind up using this in your own research. Anything I'm missing, Anton?
Yeah, so in fact, Kevin and I, we had a quick email exchange about this yesterday. There is, on the one hand, the ChatGPT interface, and then there's the API. And both are useful for their own things. There's also some overlap in which I think using either is pretty useful. I guess when you start out, just signing up for an account for ChatGPT is kind of the easiest because you don't need to learn anything in terms of programming. But then as you move on to more advanced use cases like Kevin, using the API is very powerful too.
Yeah, and maybe one thing if you're using the GPT window, the ChatGPT window, is that you can hit the reset button. It's in the top left. That'll effectively wipe the memory. The ChatGPT window is like built to have kind of a chat-like, fairly, basically implicitly, it has a temperature of like 0.5. So it has more randomness than we want for a lot of research use cases. And it's trying to remember a lot of long-term things like the context of your conversation. So you can think of this as I'm using the kind of memory of the algorithm on things that might not be what I care about. If, say, I'm changing the topic of what I want to ask about, for example. So whenever I'm thinking about something that's different than what I've written in the window before, I just hit reset the new window, and then I start from the start again to ensure kind of I'm using enough of, or as much of the algorithm's power on the actual problem I'm trying to solve as possible.
There's a question from Elise. Elise?
Hi. Thanks a lot for the talks. My question is actually for the two of you. So it builds on Raman's question. So if I have a bunch of text documents, there's a lot of different models that I can use. So you mentioned GPT and Claude, but there's also Llama. There's, I mean, every month there's kind of a new model that's coming out. Each of them has their own toolboxes. Each of them has their own cost. So what would you recommend for a use, you know, in economics? So not something like super fancy, just to analyze text documents. So yeah, something that doesn't require, you know, 6 months to learn.
Okay, so I imagine we might disagree. Basically, as far as how good it is, GPT-4 is the state of the art.
But it's also expensive, right? Because you use GPT 3.5 in your examples.
Yeah, exactly. So GPT-4 is the state of the art, but it's expensive. GPT 3.5 is, or the GPT 3.5 Turbo API is like 20 times cheaper. good enough for most use cases. If for some reason you need that, though I showed you an example in that summarization where we can for a lot of tasks still use the GPT window, and actually they offer for more money you can use a bigger window on GPT as well, and things like Bing, for instance, has the ability to search the internet, which might be useful in some use cases. But basically now, it's the OpenAI models are superior. Next year, I mean, I know people at DeepMind. I strongly suspect that Gemini will be the best model very soon, just because of the money that they put into it. And then in the long run, these Llama models, which are open source, so you can run them locally, obviously have some nice benefits, like being able to run these models locally. But unless you have quite a powerful computer, it's unlikely that you'll find this a good use of your money. Anton?
Yeah, I very much agree. It's kind of a trade-off of how much intelligence, quote unquote, do you need versus how much are you willing to pay. For lots of things, 3.5 turbo is going to be the most cost-effective, but for some things you really need the extra intelligence of GPT-4. And I'll put two links into the website. There are two websites that I find very useful that allow you to try out basically all the big language models that are out there. Poe.com is kind of a chat interface like ChatGPT where you can use all of them. And nat.dev gives you more like a playground, which is in between a chatbot interface and the API. So it's kind of a text interface that allows you to directly send things to the API and set parameters. So you can try what are the results that I get from different models if I try it out in this interface here and then decide.
Yeah, wonderful. Thank you.
Other questions? So, like, do you see like research basically being dominated by artificial intelligence systems in a few years, where from idea generation to coding, data collection, writing the paper, let's say like 90%, an overwhelming proportion of work is done by AI?
Yeah, I guess the big question is how fast this is going to advance, right? And a useful data point, as Kevin already mentioned, is going to be how powerful Gemini is going to be. And I think at this point, we don't quite know yet. In some ways, we are kind of on a gliding path to full automation, but it's really hard to predict if this is going to be within 5 years or not in our lifetimes. I do think what we can say for sure is that we are at the point where not using these systems puts you at a competitive disadvantage.
Yeah, so I agree with Anton. I would say for the task of like writing code, if you currently write code without an LLM assistant, you're just already making a mistake. It's just a waste of your time to not do this. And Copilot, or it's fairly cheap. To pay for GPT-4 is $20 a month US. These are very, very inexpensive tools. And they're all going to be, as I said, incorporated in the back end of any software you use very soon. Now, as Anton mentioned in his talk, he said the over optimism is as dangerous as the under optimism about these models. So you can think about the way LLMs work. People thought that there are problems that seemed relatively easy but need to be done 100% correctly. That's where we had a lot of focus on deep learning. It turns out that problems where getting things 99% right, but the problem is very hard, is actually a better use case. So making a photorealistic image using a generator is an easier problem than a self-driving car with a lot of data. Okay, nobody expected this 5 years ago, and a lot of these like full automation problems look a lot closer to 100% accurate than a very, very good assistant. Okay, so I would expect you to be kind of using this like an assistant as you do tasks. I would be shocked, honestly, if in a decade we can automate most parts of the research process. I would be shocked. We're just way, way, way far away from being able to do that. And even in principle, we don't know how to do a lot of these important tasks. And you actually even see this already for most tasks, like pure experts in a specific task just absolutely dominate LLMs. And people are trying to interpret or predict, like similar to chess, where early on, the chess machine was worse than Kasparov, and then the chess machine got better than Kasparov, but Kasparov playing with the chess machines could just destroy any computer. And now we're at the point where a person playing with a computer just makes the computer worse, even an expert. Okay, so they kind of took that lesson and thought that's going to apply to generative AI. Generative AI does not work like it's not just like slowly searching more and more of the kind of problem space. Like I do not think that many problems will be solvable using these type of methods. And actually, if you ask people like Jeff Hinton, for instance, who created deep learning, he would agree that I need some type of thing other than the list of tokens on the internet to actually understand the world and understand a lot of problems. And just in principle, this isn't something that AI can do, or at least we don't know how to do it now.
But Kevin, what about teaching? Like I looked at your teaching assistant setup.
Yeah.
And my school is exploring the same thing. So replacing all teaching assistants with AI-driven systems where you can actually feed the slides of your course into AI. So it has its own intelligence, but also your course material to answer questions.
Yeah. So solve problem. I mean, you can. I'll put up the new version of the code, but basically, I have code that creates like course specific TAs. We even have a backend for it, so professors can just upload like during the semester, change the content they want to be referred to. It never hallucinates, and it already gives answers for non-mathematical courses at the level of like a decent TA who I train. Worse than what I would say to a student, but better than like what a TA I've trained will say. And so we used them over the summer. We were piloting some, and I think the number of questions we got by like email fell something like 90%. So the students just now have 24/7 access, and it costs something like $1 per student per semester. So I mean, this problem's effectively solved. It's just no one's productized it yet. So you have to kind of do clunky things like just build it yourself, or you can just download the code from my site. But yes, I strongly suspect that. Well, I know this is a use case we can actually do better than current TAs in most cases. But how long will it take for this to be incorporated? The economists of innovation are very aware that diffusion is very slow, largely because institutions are very slow to adopt new technology that requires what we call architectural changes in an institution. And so at what year will your university have like a quality like LLM based TA system? I don't know, like my university was using Blackboard as our course manager until last year, which is what I used when I was in college, and I'm not that young anymore. And it was terrible when I was in college. So like how on earth did they maintain this contract? It's because I don't know if you tried to sell software to a university, but they don't move very quickly. So I suspect most institutions won't use it, but I do think there's a lot of use cases for LLMs in the world. For example, like reading like a government submission for a permit, for example, like does this satisfy the criterion on this permit? I know this is a solved problem because I work with a startup that's worked on this problem. This does not mean that the governments are using it, right? Or that they'll use it anytime in the near future. It's actually very hard to sell it to them, even though it would save them tons of money because it involves just such a radical change in how they operate. So hopefully in the future, our teaching will be able to individualize education, doing what Khan Academy and Duolingo Max and these folks are already doing, but at a higher level, at a university level. So, and our job will be deciding what the material for the class is, what the right readings are, what we need to learn, and the AI will help us get the students to the right level. I mean, that seems like basically a solved problem. So I think we'll be there. We'll be able to do it even if our university won't in the next few years.
Kevin, quick follow-up question. You're using something like a vector database for the TA system?
Yeah, of course.
Okay.
So if you don't know what Anton's asking, don't worry about it. But it's basically so there's a problem
like
called information retrieval in AI
papers.
that's well known. Yeah.
Yeah. One more quick follow-up. I think one of the challenges for us as educators is we need to really incorporate these tools into our teaching in a way that students learn to incorporate them, because they'll need that to be the most productive workers possible in today's working world. So I think some instructors have had this knee-jerk reaction, oh, let's ban these tools. And that's hugely counterproductive, because in the work world, students are going to have these tools, and the better they are able to use them, the more productive they're going to be.
Absolutely. Very good. Okay. Anyone more questions? Okay, very good. Kevin has a nice comment in chat, so you might get lots of emails. Okay. All right.
Yeah, I was just saying, I mean, many people have done this, but Anton's totally right. The universities are so concerned with cheating, and they should be. We caught a lot of people cheating using LLMs. The students know how to use them, suffice to say. So like what the text in your syllabus could be to allow people to use LLMs usefully. Actually looks a lot like what Anton said in his talk, is that LLM is a useful assistant. So if students understand LLM should be thought of as like a friend who knows this content well, their friend's not allowed to do their homework for them. They would get expelled if they did that, but their friend is allowed. They're allowed to ask their friend questions, right? And if they're worried about the yellow line, they can just tell me what they asked and what their friend did. We would be cool with that. Same idea is going to apply to LLMs, right? And so that's the rule I've used in my class, is that you're allowed to use LLMs in the same way you can use your friend. But if you want to know how much cheating is going on, the main company that students used to cheat was called Chegg. And Chegg's, it turns out to be publicly traded. And Chegg's market cap has fallen like a rock, which tells you there's a very good substitute out there that students are using. But I don't think they stopped cheating.
Yeah, I think we need to fully internalize the revelation principle here. And we'll just ultimately we just have to make it allowable that they can use these tools for whatever they are worth. And if our assignments are simple enough that ChatGPT can give an A+ answer, then I guess they'll get an A+. But our challenge is to create assignments where they can use these tools and still add their own human creativity and oversight, and checking that the system's not hallucinating and so on, because ultimately that's the most useful. It's like David Ricardo, we each have our comparative advantage, and we want the students to maximize their comparative advantage vis-a-vis the AI.
Mm-hmm. Yeah.
Thank you very much. I think we should end on this note. And next month, we'll have a seminar again on climate finance. But I want to thank Kevin and Anton for not just presenting very useful information, but also collaborating with each other to maximize the benefit of the time allocated for the talk. So thank you, Kevin, and thank you, Anton. Thank you. Thank you.
Thank you.
Thank you so much.
Thanks for having us.
Take care, guys. Thank you.
Thank you. Bye-bye.